4.3, the atom. Our learning goal for this section is to describe the electrical charge and location in an atom for a proton, a neutron, and an electron. Now, all of the elements listed on the periodic table are made up of atoms. An atom is the smallest particle of an element that retains the characteristic of that element. So here we have some examples of this aluminum foil, or aluminum foil. It consists of atoms of aluminum or aluminium. Now, John Dalton he developed the atomic theory by proposing that atoms were responsible for the combinations of elements and compounds. He was pretty amazing with what he came up with, because until this time, everybody thought, oh, well, anything was just made out of earth, wind, air, and fire. And so John Dalton was had very good thinking, and a lot of our items that we think about regarding atoms had a basis and roots within Dalton's atomic theory. And that being that all matter was made up of tiny particles called atoms. All atoms of a given element are identical to one another and are different from atoms of other elements. Atoms of two or more different elements combine to form compounds, and a particular compound is always made up of the same kinds of atoms and the same number of each kind of atom. A chemical reaction involves the rearrangement, separation, or combination of atoms. Atoms are never created nor destroyed in a chemical reaction. So those were things that he came up with. Well, by the end of the 1800s, experiments with electricity showed that atoms were composed of tiny particles called subatomic particles that included protons, neutrons, and electrons. And it was shown that some of these subatomic particles in an atom have a charge. So let's figure out. Well, electrical charges can be positive or negative. Two positives repel each other. Two negatives repel each other. But unlike charges, attract each other. So using these concepts is what helped them deduce things within the atom. So in 1897, J.J. Thomson discovered that cathode rays were streams of small negatively charged particles called electrons. He did propose the plum pudding model, which, by the way, it was proven false, okay? He proposed the plum pudding model of the atom, in which protons and electrons were randomly distributed in a cloud. Well, that's proven wrong, but he first came up with that. And cathode ray, some of you remember, maybe, a long time ago, your TVs were kind of large. They weren't the thin screen. They were large, and they were called CRT, cathode ray tube. And so it was the cathode rays that would shoot to make our TVs. So we don't want to say that J.J. Thomson's claim to fame made it where we all had TVs, but because of the cathode rays, one of the things was TVs. Well, Ernest Rutherford worked with J.J. Thomson and developed a new structure for the atom based on Rutherford's gold foil experiments. So, they thought, okay, if they shoot this beam of particles at this gold foil, they picked gold so it would be very thick. So they assumed that when they shot it, that all of the particles would just come back. If this was, since gold is dense, that the particles would just shoot straight back. Well, much to their surprise, the particles went straight through and were only slightly deflected. A few came straight back. So from that, Rutherford determined that the atoms contained a small positively charged region in the center, which he called the nucleus, but the region of space surrounding the nucleus that was around it was occupied by electrons. And the analogy was that the nucleus was like a penny, and the area that the electrons were hanging out in, or consisting of, was the baseball field. So a penny in a baseball field is the analogy. That's how small the nucleus is compared to the space where the electrons are zooming around. An atom consists of the nucleus, and in the nucleus contains the protons that are positive and neutrons with no charge. The electrons are negatively charged, and they occupy this big space zooming around. They're not just sitting there, they're zooming around. They're creating this area. So this is not like a shell, even though at some point we'll talk about shells, okay? This is just an area that the electrons are hanging out in. It's a much bigger area. It's like a baseball field compared to the size of the nucleus. Now, we talk about AMUs, atomic mass units, occasionally, but the chemists use this unit called the AMUs, which has a mass equal to 1/12 of the mass of the carbon atom. Why? Because the carbon atom has 6 protons and 6 neutrons for a mass of 12. So the atomic mass unit is 1/12 of that, giving a proton a mass of about 1 AMU, and a neutron has a mass about 1 AMU. Now the electron has such a small mass, we say that it has no mass. Now if you were in physics class, the very, very small mass of the electron would be used in calculations. But in this class, we say that electrons have no mass, and we use the word no in quotes, meaning, yeah, we know that it has a very small mass, but it's so small compared to 1 that these significant figures here, well, they aren't, okay? So 0.00055, that's not, close to 1. So compared to a neutron or proton, the electron has, quote, no mass. So here we go. The proton can be written like this, or a positive, a neutron N, or N with a 0, i.e. charge, and an electron, an E, with the negative charge. And the proton and the neutron, they have the mass of 1 AMU, and they are in the nucleus, whereas the electron is outside of the nucleus area. So which of the following subatomic particles fits each of the descriptions below? Okay, press pause, see if you can get this. So, what's found outside of the nucleus? The electron. What has a positive charge? It's the proton. What has a mass but no charge? Well, that's your neutron. Now, which of the following statements, or is each of the following statements true or false? The mass of an electron is greater than the mass of a proton. No, that's false. We know that the mass of an electron is like nothing almost. Okay, so what about the last two? Press pause and come back. Alright, so let's see. Protons have a positive charge and electrons have a negative charge. True. The nucleus of an atom contains the protons and the neutrons. Yes, it does.